Well, good evening, everyone. We're going to consider this topic together, and perhaps just by way of introduction, we can see that we live in a wonderful universe. I mean, we're part of an enormous collection of stars and galaxies, and we know we're only a small part of this thing. What can we see on the Earth? Well, we can see an amazing collection of living things, of flora, different types of plants, and of fauna, different types of animals. And all these things interact with each other in an astonishing way, an amazingly complex way. And the more scientists have studied these things, flora and fauna, the more complex they appear to be, as we shall see later on. When they could only be studied through magnifying glasses, they were complicated enough. When you get super strong microscopes on them and you start seeing molecular level, the complication seems to increase, and it's really extraordinary, isn't it? And the question arises, really, that man is the ultimate level of fauna, animal, if you like. The most developed animal that we find on the Earth today. Now our expertise is Bible study. It's not biology, but we want to just perhaps reflect on that psalm that we've read. And this is really our position as Christadelphians, as Bible students. We believe it is by the word of the Lord that the heavens were made, the breath of his mouth, or their host. So these things, we believe, come about by an intelligent creator. He gathers the water of the seas as a heap. He puts deeps in storehouses. Let all the earth fear the Lord, as we've just read. Let all the inhabitants of the world stand in awe of him. That's our position as Bible students. But of course, there are alternative ideas expressed about how these things all came to pass. There's another reference which, in the scriptures, asserts God's creative activity, the hearing ear, the seeing eye. So these elements that form part of the human body, our ears, our eyes, who's made them? The Lord, or Yahweh, as the original Hebrew says. He hath made them both. There's a quote from Proverbs. Now we've got two possibilities here. I say possibilities. We only think there's only one possibility, but you could consider there were two explanations for this wonderful state of affairs, this wonderful world in which we live. One explanation is that everything was created by an intelligent designer or a planner, God, in fact, who created each species separately. The important thing about that is that there was no... Sorry, I must have stepped forward there. There's an enormous intelligence involved. The alternative is that the things that we see around us just came about spontaneously, were developed from very simple beginnings to their present complexity through a very, very large number of very small changes arising from completely random processes, so that there was no intelligence involved. And that actually is believed by a huge number of people in the earth. They believe that the world that we see around us, ourselves, the animal and the plant world, came about completely without any intelligence being required, by a very large number of random happenings on the earth. Let's just consider that mechanism first, because we want to speak a little bit about that mechanism. Not that we're experts in that, of course. So we're going to have to quote the words of those who are, the experts in biology. And the way evolution is said to work, and does work in some respects, as we shall see. The way it's said to work is that there are two things happening at the same time. That there are, as species reproduce, there are random mutations. These are just accidents just no intelligence, no selection, just random things happen by accident. And sometimes those accidents result in an improvement in the species' ability to survive, and so more of those do survive. And that's the natural selection side of it. And so when you get those two things working together, this random mutation and natural selection, the selection of those that are stronger or are more likely to live longer or survive diseases that are around or anything that might cause them otherwise to die, then they prevail. And those two things are said to work together. Now, the most common example of this type of mechanism is the peppered moth. The peppered moth is quite a brightly coloured moth. But during the Industrial Revolution, yes, there are a lot of black smoky surfaces, and these moths were rather exposed on these black smoky surfaces, and so they tended to be prey and tended to die out. Well, they didn't die out, and this is the interesting mechanism that occurred apparently. So a very few of these moths, perhaps only one, was a little bit darker than the others, and that survived better because it was more disguised against the black surface. And so more of those prevailed. And as time went on, more and more dark-coloured moths prevailed until, in the end, they were all dark-coloured. And that was an example of a random mutation at first, followed by natural selection, the selection of those that were dark because they survived against a dark background. It was important in this theory of evolution that there is a pathway. A pathway means that these very, very tiny changes that occur have got to lead to an advantage over the previous state of affairs. Otherwise, the pathway would be broken. If there were no advantage in the infinitesimally small change, then they wouldn't occur. That's really vital, I think, to this mechanism having any effect at all. Now, there are arguments among scientists about just how far you can go with this mechanism. Clearly, it does exist, as we've seen the example of these peppered moths. And we see an example now, aren't we, with the coronavirus, which is adapting and changing. And those variants that are more infectious tend to prevail and displace the ones that are less infectious. And it's the same mechanism. So we can see that mechanism does exist and you can observe it. So there's no doubt about it. The question is, how far can you take it? Can you assert that this is the mechanism from which essentially life began, from the really simple forms and became more and more complex, and animals and plants developed faculties and abilities and features, all by a sequence of tiny changes, each one of which was an advantage over the previous one. That's the assertion. Now, not all scientists, not all experts in this field actually agree. And we're going to quote some work from a well-known character. It's Professor Michael Behe. He's a professor of biological science at Lehigh University in the USA. And he's come to the conclusion that you just cannot apply this mechanism to the existence of complex beings, of animals, and particularly of man. So he says that the current popular theory of evolution can't apply. He's a professor, and he's still there, I think, at Lehigh University. Well, I'm just going to quote some examples. So this is not my stuff now, this is his stuff, so because we're not experts in this. So let's just quote the ideas of someone who is at least an expert. He may not be the same, he may not agree with other experts, not all the experts agree, but it's interesting to take his argument and have a look at why he thinks this mechanism that we've described, this random mutation, natural selection, why it can't possibly account for the that selection of wonderfully interacting flora and fauna that we see on the Earth today. So how much can it achieve? Well, he actually did quite a lot of work on studying malaria and it's trying to find antidotes to it. Well, malaria is caused, as we know, probably by mosquito bites, and the mosquitoes inject a parasite into a person, and this parasite actually reproduces by consuming the blood of the victim, and the victim is usually dies. It's very serious. It's a horrible disease, and many millions have died, particularly, as we know, in Africa. So that's how it works. Now, there've obviously been a search for drugs to try and neutralise the effect of this malaria parasite. I won't give the proper name for it because I don't think I can remember it. I'm sure I'd get it wrong even if I could. But it's a parasite which gets injected into human beings by the mosquito. Now, there are drugs to prevent its action, and they're designed to interfere with the ability of the parasite to deal with the blood. And there's a very successful, well, there was one very successful drug. It was called chloroquine. And it really had a very beneficial effect on reducing the ability of this parasite to reproduce. That was true, but it didn't continue to be true. It only lasted for 10 years. Now, with the advent of the ability to look at the details of the genes in the parasite, it was possible to work out how this parasite had got around the vaccine. Or it wasn't a vaccine, it was a drug. It had developed a resistance to it. How did it do it? Well, it did the same as the peppered moth. There was a random mutation that gave it an advantage, that in the presence of chloroquine meant that it was more successful than those that didn't have this random variation. And in fact, the random variation that it had, which we can now recognise, arose from two simultaneous changes in the amino acid sequence. So there were two simultaneous accidents, as it were. Two accidents happened both at the same time. And when that happened, this malaria parasite couldn't handle chloroquine, and so it died away. Sorry, the one that had the variation was able to survive. The ones that didn't died away, and therefore the ones that had these two changes in the amino acid sequence became the prevalent one, just like Omicron has become the prevalent variant of the coronavirus. If a drug could achieve resistance to if a parasite could achieve resistance to a drug from only one change, then it could all happen a lot quicker. There's more chance of a single change occurring than two changes, and so it happens sooner. So resistance is developed sooner. But it needed two changes in this case of this chloroquine, and so it took 10 years. Now, this is what Professor Behe then did, was work out, well, okay, he worked out how many generations of the parasite it needed to make this change. How many malarial cells, how many of these parasites had to exist? Well, it's known that the number of malarial cells in a sick person, in one sick person, is that number there on the screen. It's what is it? It's a 100,000. It's a big number. A lot of parasite species, a lot of parasite individuals, as it were. A shorthand way of writing that is to say that it's 1 with 12 noughts, so it's 10 to the 12. That's the shorthand way of writing that big number down. Next thing you need to know is, well, how many people actually got malaria each year? Well, there were about 10 million, so that's 10 to the 7 noughts, so 10 to the 7. Those are the number of people who get malaria each year. How many, therefore, how many of these malarial cells, therefore, exist in 10 years? And it's that number there, 10 to the 20. So it's 1 with 20 noughts. That's the number of those individual parasites that are produced anywhere in the world within 10 years. And it needed that number of parasites in order to have enough chance changes for these simultaneous mutations to occur. It didn't occur before then. You took this number of cells in to achieve resistance by random mutation. There's no intelligence involved here. This is all just random. So it needs a huge number. So what this Professor Behe then did, said, well, what happens if we apply that to human beings? Well, let's take the evolutionist numbers. It is claimed that ourselves and chimpanzees had a common ancestor, and that from this common ancestor, both chimpanzees and human beings have evolved. That's the theory. And they're saying that there's about 1 trillion, that's 10 to the 12, human creatures that are supposed to have existed since this split from the common ancestor to the present day. They talk a lot about these common ancestors, don't they? Why they can't say a common designer, I don't know. Because the reason why there's a comparison with the chimpanzee is because the DNA of the chimpanzee is almost identical to the DNA of human beings. And therefore it's concluded that we must have come from the same stock, as it were, as a chimpanzee. Why didn't we come from the same designer as the chimpanzee? There are these two alternatives, aren't there? And one of them, to us, seems far more feasible than the other. But anyway, we'll carry on with the argument. So that's 10 to the 12, 1 trillion human creatures are supposed to have existed since the split from this common ancestor to the chimpanzee. Well, that's a lot smaller than the number of parasites that have existed in the 10 years that allowed them to develop immunity to chloroquine. So the chance of a human being, or whatever you want to call them, a primate, achieving a mutation of the same complexity as the dual mutation that the malaria parasite achieved to chloroquine is 1 in 100 million. So it's 1 in 100 million chance. Is that likely? No. 1 in 100 million chance would normally be reckoned as pretty well 0 chance. And remember, that is only the relatively simple combination of mutations. That's just those 2 mutations that were needed to give resistance to chloroquine. How many mutations are needed to account for all the differences between this so-called common ancestor and the chimpanzee, or our present state? Either way. There must have been an enormous number of chance mutations that would be required in order to produce the real features. Just think of all the complexity of animals, and all that's got to happen by a series of blind chances. See, these were blind chances. That this resistance to chloroquine, they were blind chances. But look how many instances there needed to be in order to achieve those blind chances. I mean, they used to say, "Oh, well, you've got an infinite amount of time, to develop. So you're bound to eventually achieve these mutations that are required." But you haven't. The scientists are not saying that. The scientists are now saying that there's a definite finite life, both to the Earth and, of course, the whole universe. And if you start working out these numbers, you find out that the numbers you need are equivalent to the supposed age of the universe. We don't need to accept that these scientists' view of the age of the universe is correct. It's just a scientific view. What we're just saying is that then it's not consistent with that view. There's an inconsistency between the view of the universe having a finite life and the view that there was enough time to produce all the mutations by chance that were needed to develop human and animal characteristics. So there's a real problem, and that problem is recognised by Professor Behe and a number of others as well. He's not alone. So that's the conclusion he came to. It's inconceivable that random mutation plus natural selection could have produced all the differences between men and chimpanzees. Now, the other interesting thing about this is that when chloroquine, they stopped using it because it wasn't working, and these parasites reverted to their original form. In other words, that random variation disappeared. So really, they did better in the absence of chloroquine. They did better without it. And that really means, doesn't it, that they'd not evolved into a higher life form. In fact, they'd evolved into a slightly lower one that only succeeded, was only prevalent when there was a presence of this drug, this drug called chloroquine. Then another problem, and this is again a problem that Professor Behe highlighted, is that as we mentioned, as we stressed when we were talking about the peppered moth, you need a pathway. You need some sequence of changes, very, very, very small changes, but each of which gives an advantage over the previous one. And there are some things that only work when all the bits are present, like the ear, for example, the eye. It needs all the bits of the eye and all the bits of the ear for it to work. So it's really hard to imagine a sequence of events that occurred, very, very, very tiny changes, each of which was an advantage over the previous one, that would lead to something where you need all the bits for it to work. I mean, if it didn't have the eardrum was missing, then it would be totally useless. So that was another problem that this professor raised. Now, there's the world-famous atheist, Richard Dawkins. It's the origin of the sign on the buses. There's probably no God, so stop worrying and get on with your life. That's Richard Dawkins. And he thinks that when this is pointed out, there are these gaps. How can you bridge a gap between a thing that has one form to a thing that has many components, all of which need to work? And he says, it'll be found. It'll be found in the future. Scientists will find the gap. And we as religious people, are just worshipping the gaps, he says. But I wouldn't call it a gap. I think I'd call it a massive chasm, which actually requires a great faith to fill. A faith in a process which is unintelligent. It really is difficult to imagine how some of these changes, these sequences can happen. And that's acknowledged by those who do actually accept the theories of evolution. It does need a lot of faith in this process, doesn't it, to understand. There's another scientist, he's worked on the genome sequencing, Gene Myers he's called. And this is what he had to say about his work. He was struck by the complexity of the gene structure of human beings. He says we're deliciously complex at the molecular level, because now we can study the molecular level. We don't understand ourselves yet, he says, which is cool. There's still a metaphysical, magical element. What really astounds me is the architecture of life, he says. The system is extremely complex. It's like it was designed. There's a huge intelligence there, he says. This is not a religious statement. This is a statement from a scientist observing the complexity of the gene structure. There's a huge intelligence there. I don't see this as being unscientific. Others may, but not me. That's an interesting thing, isn't it, for a man who's studied the complexity of the human DNA structure to say. It's almost as though it was designed, he said. It's almost as though there's a huge intelligence around here. And he's saying it's not unscientific. Let me just comment on that statement he's made there. It's not unscientific. What is scientific, in fact? What does he mean by unscientific? Well, let's just take you through a few arguments here. The first thing to say in this argument I'm going to present to you is that it's impossible to prove that there's no God. You can't prove that there's no God, and that's acknowledged by everyone, by atheists and all. It comes under a general class in philosophy of proving negatives. You can't prove a negative, and you certainly can't prove that there is no God. Science can only study the natural world. We can't study anything outside the natural world. It's impossible to do experiments on anything outside our natural world. And that, of course, doesn't mean to say science is not valuable. It's enormously valuable, but it's limited to the natural world. But it doesn't prove, does it? It doesn't prove that there is nothing beyond the natural world. Just because we can't study it doesn't mean it's not there. You can only know about it if it chooses to reveal itself. That's the only way. You can't do experiments, you can't do tests on it. How can you know about anything outside the natural world? Well, there's only one way. It's got to be revealed. And we have a revelation, we believe, of something that's outside our natural world, but has interacted with it. Now it's that interaction that's interesting, isn't it? See, there's another assumption that's made that there's never been any interference in the course of the history of the Earth by something outside our natural world. So that if scientists find very ancient creatures, ancient fossils and so on, it's assumed that they are connected with ourselves, the things that we observe today. Now that has to be an assumption, doesn't it? It has to be an assumption. You can find things that are very ancient, you can find things that are very, very recent. You have to assume, if you're saying that these two things are connected, that there's not been any interference in the state of affairs on the world between those two things. It's like assuming that there is no God that might have interfered with the course of events on the Earth. It has to be an assumption. I don't see how you can get round that statement, that you have to make an assumption that there's nothing interfered with the course of events through history, if you're going to conclude that things that are found that are very ancient are actually some sort of predecessor of what we find in the Earth today. But it's not often that people will say that, is it? It's not often that scientists will admit that this assumption is essential. But it is. There's no question about it, because you can't prove that there's no God. You can't prove that there's no God who has interfered with the affairs of the world. So it's based on this unprovable assumption that nothing from outside our natural world has or could have intervened in its history. Actually, I'll quote a passage now from Isaiah's prophecy, which is quite interesting in this respect. The prophet here is speaking, of course, to Israel. It's a long, long time ago, hundreds of years before Christ. But it wasn't the theory of evolution that he was contending against here. It was the idea that the idols were able to do things which they couldn't do. I think there's quite an interesting comparison between the idolatry of ancient history and the theory of evolution. They're both produced by men, and they both claim to account for man. They're both man-made things, and they account for man, and they are almost worshipped. Certainly the idols are worshipped, and there's almost a worship of this idea of evolution today. Anyway, this is the quote. Because I know, says the prophet, that you are obstinate, and your neck is an iron sinew, and your forehead brass. I declared them, these events, to you of old, but before they came to pass, I announced them to you, lest ye should say, my idol did them, my carved image, my metal image commanded them. You have heard, now see all this. Will you not declare it? From this time forth, I announce to you new things, hidden things that you have not known, unpredictable things. They are created now, not long ago, before today. You have never heard of them. Before today, you have never heard of them, lest you should say, behold, I knew them. So here's an interesting quotation to say, well, there are things that you're not going to be able to predict. Why? Because I do them, says God, and I do them now. They're done at an instant in time. They're not predictable from what has happened a long time in the past. They happen now. That's because there is an interference outside the natural world. There's an interference from God, we believe. And that's what the scriptures are saying. But it's interesting that they seem to address that same problem, the problem that we have in the world today, with those who claim that everything can have been predicted. Everything happened because of what the state of affairs was just before it. And there's just a sequence of events that we track through history, and you could predict it all. Well, you can't, because there is a force from outside our natural world that intervenes and does things, and they're done at a point in time now. They're not predictable from the distant past. Just want, by way of conclusion, just want to show you a video which you may have seen before, but it just illustrates and accentuates the difficulty of imagining that the living things that we see today could have come about by a sequence of small changes. I hope this works, but we'll see. There's a rather long pause here, but
evolution teaches that bacteria were one of the first life forms to evolve from chemicals. Many bacteria propel themselves with a type of miniature motor called a flagellum. These extremely efficient reversible motors rotate up to 100,000 revolutions per minute. The bacterial motor is similar to an electric motor. It has a filament that acts as a propeller, a universal joint, a stator and a rotor, and a drive shaft with bushings. Each part of the motor must function, or the bacteria will die. Since bacteria can start, stop, and change direction at speeds, they must have sophisticated sensors, switches, and control mechanisms. All of this is highly miniaturized. 8 million of these motors would fit in the cross-sectional area of a human hair. While bacteria are small, they are not simple.
Hope you enjoyed that, including the music. But I always think that it is fairly mind-blowing, isn't it? That mechanism, that detailed mechanism of bearings and stator and rotor, all the control system, all came about by a sequence of chance. It is extraordinary, you know. And doesn't it require some sort of blind faith to imagine that there's any unintelligent process that can produce such a wonderful thing? And that's the simplest life form, and it's all highly miniaturized, as the guy said. So, well, think about it, he says, yes. I'll just leave you with one quotation, perhaps summarizing what it is that God says. Know ye that the Lord, Yahweh, he is God. It is he that hath made us, and not we ourselves. So not the idols, not any idea of man can account for us. We are only accountable by the operation of an intelligent, external, unnatural being, a being which exists outside our natural world, which is, we believe, revealed to us through the words of the scriptures. So, just finally then, so which is most likely, we might ask? The universe, the earth, man came into being by chance, this sequence of chance, or by an intelligent designer? Well, we think the answer is obvious.